In exercise 4.7, we take a look at solving linear inequalities. Now, the first part to understand is what's the difference between linear equations and linear inequalities? Well, what you'll notice is we use inequality signs instead of equal signs. Now, for those of you who might have forgotten what inequality signs are, they are your greater than or less than symbols, or if it has a additional dash at the very bottom of the greater than or less than symbol, it means, for example, here, x is less than or equal to the number 2. All right, so imagine there's like half an equal sign when it's less than or equal to, or greater than or equal to. That's attached to the inequality symbol. Here we've got a nice little table. For example, here, if we look at the top row, the mathematical statement is x is greater than 2. Remember, the inequality symbol always points at the smaller term. Here it's pointing at the 2, which means x is greater than 2. Because there's no equal sign underneath, it's not equal to 2. So it must be larger. And when we put that on a number line, we use a hollow circle and have an arrow pointing at all the numbers that's above positive 2. If we take a look at x is greater than or equal to 2, well, then we have a solid circle because this number that can go where x is can be the number 2 and any number higher, essentially. And then vice versa when we're dealing with the less than or the less than or equal to symbols. Just make sure you remember that filled circles are equal to, unfilled circles are not equal to. Now, how do we prove linear inequalities? Well, it's basically the same rules as linear equations, okay? But whenever we multiply or divide by a negative number, we need to make sure the signs switch around for the inequality statement to hold true. What does that mean? Well, let's take a look at some examples. For example, in example 1, we've got some basic inequalities. Here it says, solve each of the following linear inequalities and show the solution on a number line. So there's 2 parts of the question. We need to get x by itself on one side of the inequality sign, essentially, and then put the solution on a number line. All right, we still follow our DMI process and eliminate any obvious brackets. Here we have no brackets, so we can go ahead and cross out the brackets. All right, do we have any addition terms? No, we don't. Okay, but for x take 1 greater than -2, we do have a subtraction term. Okay, so what we need to therefore do is we need to throw the subtraction term to the other side, where we basically do the opposite, or the opposite operation, which is +1 on both sides. So we're left with -2 + 1, which gets us -1. Now we can scratch out the S. After this, we don't have any division, but we do have a multiplication, okay, where we've got 4 times x on the x side of the inequality sign, which means we need to divide both sides by 4, and we have a situation where x is less than, well, -1 divided by 4 is -1/4. Okay, to put this on a number line, we need to, let's just need to draw a line like so. That looks roughly even. Let's make it a black line. Let's go back to draw, and notice how it's not equal to. So let's say this point here is 0. -1/4 could be right here. Okay, and x is less than, so we have an open circle and we draw an arrow this way. Okay, and that's all we need to do. Okay, and we can say this point here is, let's say, doesn't matter. We don't need to label the rest of the line. All right, for the next one, in equation B, we write our acronym again to eliminate the inequalities and get x by itself. All right, so if we have 6x take 7 is greater than or less or equal to 3x plus 5. Before we get into the acronym, we need x to be on one side of the inequality sign for this process to begin. So we compare 6x versus 3x. 3x is a smaller one, so we got to eliminate the 3x by subtracting 3x on both sides, which means we're left with 3x take 7 is greater than or equal to 5. From here, we got to get x by itself, and we notice there's no brackets, there's no addition, but we do have a subtraction term on the x side of the inequality sign. So we need a plus 7 on both sides, or throw the negative 7 and turn it into a positive on the other side, which means we have 3x is now greater than, well, 5 plus 7 gets us 12. And we can get rid of the s. We don't have any division, but once again, we do have multiplication, which means, 3 times what number will mean we have a solution that's greater than or equal to 12. We can alternatively divide both sides by 3, and we know 3 times 4 gets us 12, or any number that's higher than 4 will make the statement hold true. So we can say x here is equal to greater than 4. If you're unsure, always just divide. The coefficient in front of the x, which is 3, so 12 divided by 3 gets us 4 as well. Okay, and we have no indices in either equation. So once we've got our answer, we know for this equation to hold true, x needs to be 4 and higher, and we need to draw a number line. So let's put our number line in like so. Okay, let's say here is 0, here's 4. Because we have a greater than or equal to sign, we need a filled circle. All right, and then after that, we say any number greater than 4. I imagine this is like 10, then that solution holds true. Let's say this here is -3. Okay, and so on and so forth. All right, and that's how you do the basic inequalities. Just like your linear equations, it's just that we have an inequality symbol instead of an equal sign. Now, here's where we get some harder inequalities where we might have to divide or multiply by negatives. So what you'll notice is, just check that this is it. So what we need to notice is we still need to get the pro-numeral by itself. So we still need to write our acronym as TMI. And the question just says for us to solve each of the following linear inequalities, which means we don't need to put a number line at the bottom. All right, so what number does m have to be for this equation to hold true? Well, we need to do our linear equation rules. So we think -3m plus 5 is less than -7. We check the brackets, there's none. We do have an addition term on the m side of the inequality sign, which means we need to get rid of the +5. So to get rid of this, we need to subtract 5 on both sides, or we throw the +5 and turn it into a negative on the other side. So if we were to subtract 5 on both sides, we would have -7 take 5, which would get us -12. And from here, we can cross out the A because there's no more addition terms in our second line of work. There's no subtraction, but what we notice is there's no division, but a multiplication. But here we have a situation where we need to divide both sides by -3. So what's really important is we think to ourselves, well, what's -12 divided by -3? We know -12 divided by 3 is 4. Okay, and then the two negatives would cancel out. But it's really important for inequalities, whenever you divide or multiply by a negative to both sides, you need to flip the sign. Okay, because if we were to substitute 4 into this m, okay, for example, -3 times 4 gets us -12 plus 5 gets us -7. So notice how -7 is, I guess, the point where it's equivalent to the right side of the inequality. Now, if this was a, so let me just re-explain that. So notice how we substituted it in, the left side equals -7. What this answer says is the m value has to be greater than negative or greater than 4 for this inequality to hold true. So if we were to substitute 5, 6, 7 into this m at the start of the equation, then we know it's going to be less than -7. If we were to have this inequality symbol the same, saying m has to be less than 4, well, then the equation won't hold true. Okay, if you have any questions, let me know in class and I'll prove it to you on the board. Just know that every time you divide or multiply by a negative to both sides, you need to flip the inequality sign. Okay, so for the second part, we have brackets. So here we need to expand the brackets out. So we need to go 5x take 10. Okay, using our single bracket expansion rules, we have 7x plus 21. Okay, because 7 times x, 7 times +3, and we've eliminated the brackets. From here, we need to get x on the same side. So here we've got 5x versus 7x. We know 5x is smaller, so therefore we have -10 left on the left side, and we have 2x on the right side because we have to subtract 5x from both sides and a +21. Right, now that the x is on one side of the inequality sign, we can prove, I guess, keep going with the acronym. So on the pro-numeral side, do we have an addition term? Yes, we do. We have a +21. So we need to subtract 21 from both sides, which means -10 take 21 gets us -31. And then from here, there's no subtraction terms on the pro-numeral side. There's no division, but we do have multiplication. And what we need to do is we need to divide both sides by 2. Which means we have a situation where we've got -15.5 is greater than or equal to x. Okay. So just one last thing. Notice how we divided by a +2. Okay, and we add a negative. Because we divided by a +2, the sign doesn't need to switch. Okay, it's only when we need to divide by a negative or multiply by a negative, that's when the sign, inequality sign, switches. Okay, and again, if you would like to see the proof, I'll show you in class. Thanks, everyone.